Welcome you all to the course on discrete time signal processing. This video lecture is about programming for circular convolution. It's a part of your unit 5 DSP processor. Before entering into the programming of circular convolution, let me explain the concept of circular convolution. Similar like linear convolution, so here also we are going to have two sequences called x of n and h of n, where x of n is nothing but your input to the system, h of n is nothing but impulse response of the system. Okay, then output of the system can be expressed as y of n is equal to x of n convolution with h of n. Okay, so here if I have n number of samples in x of n and m number of samples in h of n, then obviously my output will have maximum of m comma n number of samples. In the linear convolution we had n plus m minus 1 number of samples, but here maximum of n comma m number of samples. Okay, so here I have taken two sequences for the explanation. So here x is equal to 1 2 3 and h is equal to 3 2 1. Okay, so we are going to perform a circular convolution for these two sequences, and the same concept will be explained in the program also. Okay, so which means that number of samples x is equal to 3 and number of samples h is equal to also 3. Okay, so once again ash include stdio.h, it's a standard input output library file, and we are starting the main function. So I am defining pointers. Okay, xn, that is x of n, hn, that is h of n, and output y, and the length of x and the length of h. Okay, I am defining this all as a pointers, and for other variables I am using I, n, m, a, b, l and k. Okay, so initially I have assigned the memory location for my input address. Okay, sorry, for my input. So my inputs are stored in the address of 0000 and so and so. Okay, which means that here I have assigned x is equal to, sorry, 1 is equal to the value 1 is stored in the 0. Okay, the value 2 is stored in the location of 1, and the value 3 is stored in the location of 2. Okay, here I have written the program such a way that I can maximum I can load 100 inputs. Okay, then I have started my h of n sequence. Okay, so h of n sequence is also, sorry, the address is starting address is 100, which means that in the 100 the value will be 3, in the 101 the value will be 2, in the 102 the value will be 1. Okay, after taking all these inputs to x of n and h of n, I should assign the output address. Okay, so here I have assigned the output address y is equal to 1000. Okay, and similarly we can take the length of x as well as length of h to the variables xn length and hn length. Okay, as of our explanation, the xn length is 3, hn length is also 3. Both are stored in the address of 10,000 and 1 lakh address location. Okay, now we will start the program. So a is equal to, so I am assigning that pointers to the a, so which means that here a will be 3 and b is also 3. Okay, so after taking this I should assign the output variable, no? So then I should know the number of outputs, sorry, number of samples in the output. Okay, which already we discussed. So that is nothing but maximum of a comma b. I am assigning that to the variable k. Okay, so once again it's the initial step. Okay, so initially I am going to assign I is y of 0 is equal to 0 and x of 3 is equal to 0 and y of h of 3 is equal to 0. Okay, this will be taken for n number of iterations. Okay, next we'll move on to the main programming. So this is the circular convolution program. So once again I should take two for loops. One is outer for loop, other one is inner for loop with the variables of n and m. Okay, so n is less than, sorry, n is equal to 0, n is less than k, and here we know k is nothing but maximum of a comma b, which is nothing but 3 for our example. Okay, so the outer for loop also will be executed 3 times. The inner for loop also will be executed 3 times. Okay, so in the sense, whenever n is equal to 0, your m can be 0, 1, 2. Okay, similarly, when n is equal to 1, your m can be 0, 1 and 2. Okay, this will be continued. Okay, so now we'll go for the main portion of our programming. So I am assigning L is equal to n minus m. Initially n is also 0, m is also 0. Okay, initially L is also 0, m is also 0. Now let me check the values of L. L is nothing but n minus m. So n is also 0, m is also 0, which means the L is also 0. Okay, now I am checking whether my L value is lesser than 0. Okay, whether 0 is less than 0, no, condition failed. Okay, then I can go for my output line. So y of n is equal to so and so. Okay, here the value of n is equal to 0. So y of 0 is equal to y of 0 plus x of 0 into h of 0. Okay, so yeah, here x of 0 is nothing but 1, that you can take from my input, and h of 0 is nothing but 3. Okay, so 1 into 3, 3, 3 plus 0 is nothing but 3. Okay, and that is the first value, this one. Okay, 1 into 3. Okay, now we'll go for the second. Okay, so n is equal to 0 and m is equal to 1. Okay, n is equal to 0 and m is equal to 1. So which means that L is equal to n minus m. So 0 minus 1 is minus 1. Okay, whenever value is less than 0, I should add the k value with L. Okay, since L is becomes less than 0, I am adding k value with the value of L. Okay, so minus 1 plus 3, so will become 2. Now we can write y of 0, sorry, y of 0. Y of 0 is equal to y of 0 plus x of 1 into h of 2. X of 1 is 2 and h of 2 is 1. So 2 into 1, 2. So the previous values of y of 0 is nothing but 3. So 3 plus 2 is 5. Okay. Now once again the inner for loop will be incremented by 1. Now m will become 2. Then L will become minus 2. So now we should add plus 3 with that. So the updated value of L is equal to 1. So y of 0 is equal to y of 0 plus x of 2 into h of 1. After taking the x and h value from the input, now your y of updated value of y of 0 is equal to 11. That's your first y of 0. Okay. Now if I increment the value of m, so now m will become 3. Okay, so for m is equal to 3, your inner for loop will be terminated, that will not be executed. Now we should go for the outer for loop. Now I should take the value of n is equal to 1. Okay, then I have to continue the process. Okay, for n is equal to 1, I should take m is equal to 0, m is equal to 1 and m is equal to 2 and so on. So and similarly I should take the values of n is equal to 2, then m is equal to 0, m is equal to 1, m is equal to 2. If I perform all those things, then finally I will get y of n is equal to 11, 11 and 14 as my output for the given inputs. Okay. Thank you. That's all about this video. So if you have any queries regarding this, you can mail to arunkumar@savitha.ac.in. I am ready to clarify your doubts. Thank you.